Welcome to live stream number 136. My name is Lars Christensen, and thank you so much for joining today's live stream. Whew, it's Friday, man. We made it. Hope you have a good weekend planned. I am excited about today's topic. We are live. That's good. I am super excited about today's topic. Actually, that's how I should put it. So we got David here. Absolutely appreciate it. Today's topic, it's CAM. So if you're not interested in CAM, then maybe this is, maybe you should go and do something else. But if you're not into CAM and Fusion 360, we're going to talk about form tools and probing today. It's two topics that are very interesting. Now, just want to show you where we have kind of like lined up here in regards to what we have in the software. The reason I'm excited about this topic here, and I've talked about this on some other webinars you maybe have come across. This is kind of like a layout that is similar to some of the stuff that I used to do in the past when it came to doing manufacturing. I've always hurt me a little bit if you're walking in. This is like the table of like a Haas VF3, like a fairly big CNC mill. Always just hurts me when I walk in and I see like one single Kurt vise sitting on the table. But today we're going to talk about probing. And this was requested by a couple of you guys who sent me emails. By the way, my email address is down in the description area. Send me an email for any future topics. Some people wanted to ask me to do a quick live stream on the probing. So that's what we're going to do today. But I couldn't help myself. I want to show you a cheap man's probe too. Because primarily when we're talking probing, we're talking spindle probes. But as you can see here on the screen, over in the lower left, we also have a touch probe style. This is a Renishaw. It could be other types. But I actually did a fairly amount of production programming when I used to work at Ridlam. And one of the issues I had was that when people load parts up in a vise, especially when they're running more than one, misloads. So I actually used a graphite stick to check the parts, and then because I didn't have a spindle probe, I would come over on a table probe like this and check that. So that's where we're going to use the form tools that are inside of Fusion to do that. Now these table probes here is normally used to check like tool length, and then if your tool broke. I looked up these Haas ones for Haas is about $1,500 for one of those brand new. Probably buy them used, but having these are definitely nice. It's the spindle probes. They run a little bit more than that. So I understand if people don't get those. But I would definitely prefer to get some kind of a touch tool if you can, if you maybe are considering it. But first, let's go in and talk about the standard probing tools that are inside of Fusion. I'll give you a quick view of those, talk a little bit about how they work, and then we'll get in and I'll show you the form tools, and then how I did this. I call it my cheap man probe, what worked really, really, really great. So, inside of CAM here, let's talk spindle probe. I have some parts sitting in some different vices. And this is kind of like how I used to try to do some things on certain projects. So, one set of parts on an A-axis over here. Then I have a vise sitting here with a little fixture. Actually, I have some Mighty Bites that holds these parts. And then I have these vices here. What are like module vices. You can slide the jaws around depending on how big your parts are. Now, these vices are actually sitting on a plate that I could take out of the machine. So, you could load these parts up for like night runs and have a standard vise on the machine during the day. And then at the end of the day, take the standard vise out. You plug this whole assembly of vices in. And you might need somebody to help you carrying it. And then you can just hit the green button and go. But the standard probing tool, we're going to concentrate on like these parts here. So what we can do inside of Fusion, and this is pretty cool, is we do have probing cycles in here. Primarily this is used for picking parts up. Now, I know that the development team are working on some other things down the road, but for right now, let's just talk about picking this up. And I'm going to show some code too. So if I select the probing cycle, we get a standard probing menu. It works like anything else. We got to go ahead and select the tool. So click in, you get the tool menu here. Now down in the sample area, there are some different sample probes. So be aware of that. Let's select the 6mm. So this is just like when you are doing, standard tooling. Now, what is neat about this, when we go over to the geometry, check this out. I'm going to zoom in on this part here. If I select on this face, just left click, and I hope you can see it. We get a rapid arrow down, and then we get a arrow showing us that it's going to come down and probe this X side. Now if I then select this face, you will actually see that now it selects both the X and the Y, meaning that it will actually create the pickup corner right on this corner here. So this this probing in here is fairly intelligent depending on what you select. Now if I just X out of these two faces as selected, and I, for example, select this top, then you will see that now it actually selects all four sides of it and finds like the center of the part. But it's probably what I would do with something like this. But just so you know, I want to show you. You can also in here select the Z, and then you can actually select where you kind of like want it. So if you just wanted to find the Z axis, you could switch this over to Z, and it will find that. I'm going to go back here and select the center here. So what the probe cycle does here, I'm going to hit OK to this, is that it creates over here a probing cycle. Now let me just simulate this so we can kind of see it. I'm going to slow it down a little bit. So the probe comes down and it selects the four sides in here and sets our work coordinate system. Now, just so we have another tool path in here, I'm going to go in and select the facing operation. I'm just going to select a metric, like maybe a 16mm flat end mill. And I'm just going to face off like this face here. Okay. I want to make sure we have a probing and we have a facing operation. So now the probe will come down, pick up the part, and then it will do a facing operation on the part, or maybe facing, maybe it could do the pocket, or some other kind of operation. Now, where I think that there might be a little bit confusion, or, I mean, this kind of stuff very quickly can become a little like, a little scary maybe, is in the order of how this whole thing works with selecting the work coordinate system. And this is where, if I do a good job, thumbs up. If I do a bad job, thumbs down. If I do a good job, then hopefully you walk away now and be like, okay, now I get it. So what we have to do is we have to tell the program where this part is, right? And then we're using the spindle probe inside of your mill to pick this part up. Now, when we go into the setup, right click, edit the setup, and we go over to the last tab, the post processor, this is where we put this in here. And this is where I think that there might be a little bit of confusion about what happens where. Well, it's the way to remember this is that the work coordinate system offset, your G54, G55, or wherever the part is, that will not change because you're using a probe. That will still be where you want the program to start on the part. So make that, straight out of the box. That will not change. The probe work coordinate system override, and this is where it gets a little bit forget about the override. The probe work coordinate system is where the probe is reading from. So the probe, right? The probe's gonna come down and pick up your part. Now the probe needs to know where it is. So it needs to come down first and pick up the part, and then it tells, when it has found the part, it tells the machine, this is where the part is. So you normally would have two different work coordinate systems in there. Now, when we bought a new house with a Spindle probe on it, the guy who set it all up, he decided that the probe was G54. So that meant that so the probe will just always be G54. Don't change that. That means that all your parts on your machine will be G55, G56, G57, G59. Okay? So that means that in that setup, if we go back in here and look at this, that means that for my part, that will be, for my probe, that will be G54, which is either 0 or 1. I like to do that 1. G54 is 1. And then if we want to make this part G52, that means that we make that, not G52, G55. We want to make the part G55 pickup, that means this will be number 2. Okay? Now I'm going to post this out now so we can take a look at it. I hope that this is not too confusing. Maybe if we look at the code, that will be better. So let's post this out. I'm just going to post it out here. Yeah, whatever. Override, that's fine. It's going to open up on my other machine here. Okay. So what happens if you look at the program, and I hope this just makes you feel better, is that when you come down to the probing cycle, it's going to call up the tool. In this case, it's tool number 6, whatever. It calls up G54. That's for the probe. Okay, and this is how when my house was installed, that was set up like that. And then in the probing cycle, and for some people, this is what is called macro programming, by the way. I'm going to talk about this in a second. These call up these sub-programs to run these macros. In here, it then sets the G55. You can see that is called down here. So if I call up Fusion again, let's go in here and edit here and go to the post processor, and then let's call this in and make it a little bit smaller. So the probe work coordinates override, that's right now set to 1. That's G54. And then we set where we want, when it have found that part, then we want to use G55, number 2, there for running that part. Okay? So I hope that this makes sense. Now, I have to be honest with you. When the guy, after they installed the machine, when they left, I don't like to be told what to do. I was like, I don't like not having G54 available as my program, because hey, I sometimes want to use G54. Nana boo boo. So what I did was I put the probe, I copied what was in G54, and I put that into G59, because I rarely use G59 as a work offset. So that way, I could use G54. I could override G54 if I wanted to. G59 was where that ran from. So what I did inside of Fusion would be to just change this. And in Fusion, 1 is G54, 2 is G55, 3 is G56. So that means if I change this to a 6, that will call up the probe as a G59. And then I always used that, and that meant I could go switch back and make this 1 for this if I wanted to. So if we post that out, regenerate, we post that out. Now you will see that it's going to call G59, and that was just what I left it at. It was just sitting in G59, and my tool, by the way, was always, I think, tool number 9, I think, or something like that, whatever the highest number was. And then now it shows G54 down there. So let's just go back again and just edit this setup. So that was how I had it. But I think that confusion is overriding. That word is maybe a little confusing. So this will be whatever the probe is signed into, and this number here is associated to these parts. Now I want to say a couple of things. First of all, and again, I hope this is useful. First of all, if this whole probing is still a little confusing to you, and I don't blame you, down in the description of this video, there is a link to Tim Paul's lessons that he created that is out on the Fusion website. If you're not familiar with Tim Paul, he is one of the guys that works at Autodesk, and he's smart as a whistle. And he did a really good series on this whole video. I would definitely go and check those out. Another piece of advice I would give you, and then we're going to get to the form tools in just in a second, is that when I posted this out, I talked a little bit about macros. And this was something that was, let's post this out again. This was something that was really foreign to me for many years. And I'm kind of sad that it was. This whole, if you go and ever looking at this case here, the Renishaw probe cycles, it's all these macros that it's using to executing all these operations, and macros are used all through your machine if you're fairly new to machining. So like if you have a tool changer, M6, that's a macro. There is a really great book. Again, I left that link also down in the description area of this video, that I bought when I worked at Ridlam, and it opened up a brand new world to me. So if you are maybe if you're a guy if you have a CNC machine that can do macro programming, you should at least go to the library and borrow this book. That can open up all kinds of things. Okay. Man, exciting, it's Friday. Now I want to talk about the cheap man's probe, because this was something that I did that I was really thrilled about, really happy about. So on our machines, we have these table probes in here, and actually you don't even have to have one of these to do this cheap man probe that I have, because visual on these will absolutely work. So one of the problems I had was that, when people are loading parts into a vise like this, you can have stops in there, but at some point people don't push it up against the stop. It just happens. And then suddenly a part is sticking out a little bit too much. The tool comes down, the tool breaks, it's terrible. Somebody gets mad. It always happens around this time on Fridays in the afternoon when you gotta go home. Oh, it's terrible. So what I did was I created my own probe that I used. I'm going to open up a new document here, and this is going to kind of like tie in with the form tools that you can do inside of Fusion. So let me start a new sketch here, and I'm going to sketch on the front face. So what I came up with was a 2-point rectangle here. Oops, get into the origin. Snap in there. Let's make it 2 millimeter times 150, like that. And another, I'm gonna try to do this all with rectangles, just because that sounds fun. 2 millimeters by 18. No. Oh, Control Z forward. Hey, give me that back. Here we go. 1 millimeter. My mouse is moving. By 18 by 1. Okay. And then another rectangle. I wanted to do it with rectangles. Another rectangle like this. This is going to be 1. And this is going to be, let's say, 5. And let's make the distance between here and here 10. I appreciate your patience. Okay, let me reroll this. So what I came up with was something that looked like this. I bought some graphic rods. There's like 150 millimeter long graphics. Now graphics rods, you can buy them like if you're doing Sinker EDM, for example, and they're fairly cheap. They cost really not much. And then I would go in, I would have the grinder guys grind them down from 4 millimeters down to maybe they were 8 millimeters. Maybe they were 8 millimeters in diameter. I think they were probably 8. Now I'm thinking about it. 2 is... How does this look? That might look more right. But that's gotta be changed to 2. So so these were just, I bought like a handful of these, like 15 at the time. I had the grinder guy because graphite is easy to grind in. I had him grind this down like this here, okay? And the idea was that then I would create a tool path where it will come right along the edge here, and if one of these was misloaded, then the tip here would break off. And then either when the tool came over to the table probe, or visually, you could say, you saw that was broken off, then you knew that one of the parts was misloaded, and you now didn't have to, break any tools. Now it was a, 25-cent rod that you could regrind again afterwards. So let me show you how the foam tool works with something like this. So I'm just going to go ahead and I'm actually going to delete the solid. I'm really only needing the sketch for this. And the sketch, and I'm actually going to trim the edges so we get that thing that we actually, like the shape of what we need here. And then of course by deleting those, then I lost my my dimensions here. I thought I just changed that to this here. No, I did do that to 4, that to 2, that to 18. Perfect, now it's fully defined. So you draw up half of the tool that you want, just like you do when you revolve. So I hope that this kind of like made sense. So like, that was why I used the revolve function. But now I have it as a sketch. Now here's a cool thing. Whoops. Turn the sketch back on so you can see it. You can even right click and show dimensions if you want to. Now here's a neat thing if you didn't know this. If you go into the CAM environment, over here under manage, we can create form tools. So click on that and we get this form tool menu. Now I'm going to just go back to the front view here and look at it. And the first thing it's talking about is the tool profile. That's going to be like the whole profile we just selected. It's looking for a tool axis. That's the same thing as like the revolve around axes. Just like that there. It has a flip axis. And if I zoom out, you'll see we have an arrow up here. You want that arrow, I think, always to point down. And then a compensation point. Where is the point that it should compensate from? Now for me here, I could maybe select this corner up here, but I think I would rather like to control that. So I'm going to select this corner down here and hit OK to that. Now nothing happens on the screen when I hit OK. Don't worry about that. What have happened though is that if I go up and click on our tool library inside of the CAM, up here in my file, I now have that brought in right there. Now it's sitting right now existing in this file where I just drew up the sketch. So what I'm going to do instead is in my local library, I'm going to right click. I'm going to create a new library. I'm going to name that probe, if I can spell, probe. I'm going to take that form drill from the document. I'm going to drag it right down in the probe folder. So now it's sitting in there as a probe, what actually means that now I don't care about that file. But before I do that, let me just go in and right click and edit the tool. So you can see it in here. If you do have a table table probe, then you can turn on break control on the last tab in here. And now at the end of the cycle, if you have a table probe, we'll go over and actually check if it's there. If you don't have a table probe, you could just visually take a quick look. Gonna hit OK to that. Exit out of this. I actually don't need this profile anymore. I'm gonna save it anyways though, just because if I don't, somebody's gonna ask me for it. Okay, save that file. Exit out of that. Now, so what I can do in here is we can now go in and do something like a contour toolpath. Select tool. Let's go into that probe folder. Select that form drill. Here's our little graphite probe we just made. And select an edge here. Now, if I go down here and I select here, you will see that it selects the whole circumference. Don't forget, you can select it again, and then this little selection menu will come up. I'm just going to select an open contour. So that shows just that line, and hit the little green check mark. So now it's only machining that. Now, I'm just going to hit OK right now so we can take a look at this. So if I go into the right view here to the side, and we simulate this, you see here's the probe. It's going to come down. It's just going to touch that compensation point right on the edge. That's not what I want though. So I'm going to go back in and edit that again. On the height tab, I'm going to go minus, remember I made it 19. I'm going to go minus 19 because then on the passes tab, I'm going to turn stock to leave on. That is going to be the tolerance that I would make this block be a little bit too big because we need a little bit of clearance. So if we go in and simulate now, you will see if I zoom in, we have a little bit of clearance in there, 0.2 millimeters, whatever yours is. If that part there is sticking out too far, let's say we put the stop on the inside, that little tip there will snap right up because it's just graphite. And when it goes over on the tool probe, then it would notify that it's broken and not be used. Now, just so you know, because somebody's going to say that in the chat right now, that if I go back into selecting these, if you just want to select edges like this, if you can also, instead of just clicking on the same edge twice, you can also hold Alt down or Option on a Mac, and you can multi-select, and you will only select edges like that. So that's a way to create this, right? When we're about the end here. Let's hit simulate, and you will see that now testing the parts. Oh, and no, this is, I get to show another thing. Notice how it's actually doing it out of order. Like, I don't want it to start in the middle, go here and go here. I kind of like wanted it to start in one end and go along. If you go into, this is contour operations, and into the passes tab, down here, preserve order in the passes tab. If you check that, now Fusion will select in the order that you picked it. Okay? So now this of course will go, above any tool paths. But now if you look here, now that probe, Spindle probe, will come in here. Now if I don't have a table probe like this one over here, then of course I would just put a stop in my program and have the operator open the doors and look to see if that that little tip there was set. How was that? Was that useful? I hope so, man. Covers, I think, some good things in here. The Spindle probe, if you have one of those, they're really sweet. You can do a lot with them too. So like I talked about before, inside of Fusion right now, we use them as a pickup of the part. But I actually ended up using it also almost like a CMM within the mill to inspect the parts afterwards and things like that. That's where macro programming becomes really good. Look down in the description area of the video for a Amazon book that I really liked when it comes to macro programming. Also, if this whole Spindle probe is new to you and Fusion, check out Tim Paul's great videos. He's awesome. And this little cheap man's probe, whatever you want to call it, I hope that if you are running multiple parts, that you will find that helpful. That's all I got, man. Just when the clock switched to 30 minutes, I really appreciate you taking the time to watch these videos. Thumbs up if you like it, thumbs down if you don't. My email address is down in the description area if you have any future topics you would like to see. Just like today, that was one of them. I want to be better at incorporate those into these live streams. Man, I hope you have an awesome weekend. If you're watching the recording, thank you so much. And if you're in the live stream, I'll come in and say hi to everybody. Take care, folks.